Hello everyone, this is Janani from Tech Engineering College, Department of Computer Science and Engineering. In this presentation, I'll be explaining you my project work phase 2 titled Enhance Violence Reduction using Inception V3. My team members include Dheepica and Hestia Jessica Paul. This is basically the outline of the presentation. Let me begin with the problem statement. So the problem statement is to tackle the challenge of real-time violence reduction by leveraging deep learning model to identify threats swiftly and most importantly accurately. So in abstract, our project aims to develop an automated system for detecting violent actions in real-time video footages using the advanced deep learning model that is Inception V3. Inception V3 is specialized in action recognition and object detection. Thereby, it helps to improve the accuracy and efficiency of violence detection. These are the objectives of the project, that is to extract the key motion features using Inception V3 and of course detecting violent actions with a high accuracy and minimal latency and ensuring scalability and efficient performance. So the existing system often faces challenges like, as I said earlier, false positives and negatives, which ultimately impacts the detection accuracy. And the existing system also fails in real-time processing with minimal latency as it requires significantly computational resources. Also, the scalability remains an issue for systems as in this case for violence detection, we try to handle with diverse environments with varying input types. As for talking about the proposed system, the deployed system provides rapid detection of violence detection as we are using Inception V3. The system design focuses on minimizing false positives and negatives, again, ensuring reliable alerts for security teams. And most importantly, the system offers enhanced context awareness, identifying violent or non-violent behaviors correctly. And these are the modules of our project, which include data collection and pre-processing, model selection and fine-tuning, feature extraction and classification, and real-time processing. So the first module will be data collection and pre-processing. In this module, we have selected the dataset, that is UCF crime dataset, which is a large dataset that contains almost more than 100 videos of both violent and non-violent categories. The dataset was non-labeled, so we took the task of doing annotations and labeling using the website label image, and also we did bounding boxes to particularly specify the region that we need the inception to detect the action for. And the module 2 will be model selection and fine-tuning. Why we selected Inception V3 as for till the previous slides, I have said all these points like efficient feature extraction, better generalization, handling variations, and pre-trained availability. Yes, the Inception V3 that we are using is already pre-trained for object detection, but we are using the pre-trained Inception V3 to help our purpose, that is to detect violences. So how we are turning the pre-trained Inception V3, which is just used for object detection, into the violence detecting Inception V3 is through fine-tuning, which we'll see how in the next slide. So this is basically the fine-tuning process. First, we loaded the pre-trained Inception V3 model. We froze the initial layers. We freeze only the initial layers to retain the general spatial feature extraction capabilities. Then we add the custom layers, and finally we trained the Inception V3 on the UC of crime dataset, which is perfectly ready with annotations and bounding boxes. And the third module is feature extraction and classification. Addition to the Inception V3, we are also using Vision Transformer for the purpose of classification. The output from the Inception V3 is given as input to the Vision Transformer. It perfectly classifies the output from Inception V3 into different labels such as violent or non-violent. And the fourth and final module will be real-time processing. So this image shows the complete workflow of our project. First, we get the input data in the form of a video feed or webcam, and the input data is passed to the Inception V3. If the video is in the if the input is in the video or live video format, the it is sent to the Inception V3 as frames per second. And then Inception V3 will identify the human actions in each frame, and the output will be again passed to the Vision Transformer as I've explained earlier. The Vision Transformer will classify the output into three categories in our case, that is all good, normal, or violence or danger detected. And finally, the output generated label will be displayed on the input itself. As for speaking about the hardware or software requirements, we are using Python for programming language. PyTorch has deep learning libraries, and of course OpenCV, as we are working solely with images and videos. And model framework will be Inception V3, and we use NumPy and Pandas for data pre-processing module. Hardware requirements are GPU NVIDIA, 16 GB RAM and SSD. These are the output screenshots. The image right now you are looking is the admin login. We have particularly made this so that only the authorized admin can access the site. And this is the home page. This is the interesting part that I've told you about, that is we can select the input type, like we can give an input, we can say, feed the system with images, video files, or we can connect the webcam and stream live video. And these are the sample predictions that our system generated for different data types. And the figure 6 that we are looking at is the prediction for a live video, prediction for a video, recorded video. And this is the log data, which is solely used by the admin. And we have come to the end of the presentation. And the deep learning model successfully classifies the scenario, enabling accurate and efficient violent detection for more than 85% in our case for real world surveillance. And these are the references. Talking about future enhancements, the Inception V3 and the Vision Transformer model can be further improved by training or fine-tuning them with even more larger data sets, so that the feature extraction and classification capabilities will be furthermore enhanced. And they can also we can also focus on handling occlusions or low light conditions, so that it will make it more effective in real world scenarios like crowded spaces or dim light areas. And thank you.